All right, our last video over here is using the information given to find the standard deviation and the mean. All right, so we are just going to combine the inverse normal and then also the simultaneous equations, and then we can find the mean and the standard deviation. This is the information given over here. That x normal distribution, the mean is unknown and the standard deviation is unknown as well. So if you can put this information on the diagram, you can see that x, this is the mean mu over, if this is the mean mu over here, and then the probability that x is less than 66 is 0.0359. You can see the probability is very small. That means this 66 is going to be on this side over here, that's 66 over there, and this is the less than side. So this one here is 0.0359, and this one over here is 81, greater than 81, and the probability is too small. It's not it's less than 0.5, so that 81 should be on this side of the mean, and this area over here is 0.1151. So now all we need to do over here, the first thing we need to think about here is to find the z values that are responsible for these probabilities over here. The z value responsible for these probabilities over here. So for this one over here, remember it is in the negative. So if you have the z over here, the z value for this one over here, for the 66, is going to be negative z because it's on this side over here. So, but you're going to reflect it onto the positive side. So this area here is the 0.0359. So we are finding the phi inverse of this area over here. And so when you subtract 1, you have 0.9641. So we are finding the phi inverse of 0.9641. By this point, if you are watching this video, you should have gone through from videos up to from video 1. You should know how to use the table over here, and our phi inverse is going to be 1.8. And for this one over here, for 81, I can use another color over here. For 81, you'll find the phi inverse of all this one over here, all this area over here. And if this is 0.1151, that means it is 1 minus this. So I find the phi inverse of 0.8849. So I find the phi inverse of 0.8849, and that phi inverse is going to be 1.2. So for 81, the z value is this is the z value, all right, and this is the z value for what? For 66. Now we go ahead and say, how do we find the z value? We find the z values by standardizing this value. And how do we standardize these values over here? For 66 is going to be 66 minus mean mu, which is unknown, over the standard deviation sigma. But we are saying that the value is negative 1.8. And when you move the sigma on the other side, that means you have 66 minus mu. This writing is not good over here, so I'll try to erase it to make sure it is better. All right, so you have 66 minus mu equals to negative 1.8 sigma. Now this one equals equation 1. Now when you look at the 81, it's going to have 81 minus mu over the standard deviation equals to 1.2. So this one was negative 1.8. This is 1.8. This is 1.2. Remember, this is negative because the 66 is on this side. And when you look at the z value of the 66 over here, it should be a negative value. All right. And that means we have 81 minus mu equals to 1.2 sigma. Hope this makes sense. So this is the equation 2. So your aim now is to solve equation 1 and equation 2. I'll change the color over here and I write my equation up here. So I have 66. Okay, what do you have over here? Now we will go back and use our normal equation over here. So we have 66 minus mu. Now at this stage, everyone knows how to solve these simultaneous equations. Then you have 81 minus mu equals to 1.2 sigma, and then you can solve this equation simultaneously, and then you find out that your sigma is 5, and then your mu should be 75. So when the sigma, sometimes you can find when only the sigma is missing or when the mean is missing, but the logic here is that you find the inverse normal and then come back to your standardization, which we have been always using. You come back to standardization, you come with your two equations, and then you solve the two equations. Then you get your mean and the standard deviation.